All right. Good morning, everyone. I'm Ben Pick, and this is Jack Manio. We are going through to discuss the cloud native infrastructure and how things have changed and some of the security pitfalls that you can go through that you need to address that weren't in traditional pipelines. So if you want to move us along.
So I'm Jack Menino. I've been working at Invisium since 2009. Sometime in between the rest of my work, I get to write a little bit of code. Do most things in Scala and Go these days. Any Scala programmers in here? Okay, good stuff. I do think a lot of things about scale these days. I worked for years doing penetration testing. It's not particularly fun to find bugs anymore. I'm definitely more interested as part of my career in solving things and making it damn near impossible for attackers to get in.
Thanks. And all right. And I am Ben Pick. I'm an application security consultant with Invisium. And my former life, I was also a agile and DevOps consultant. So I would go in, assess various teams, and give them recommendations for how they can improve. So some of the lessons learned from that are that we're applying in this presentation is you need to really just take full advantage of the systems that you're using and make sure that they integrate properly within your pipeline and more recently within the cloud. So this right here is your traditional pipeline. You can see in the lower left your developer. They are committing their code into Git. It moves in a very linear fashion through each of the various phases of your environment. So from dev to integration to staging to production. And you can see this very, very linear fashion of your developer committing the code and it going directly into production. Now at each stage, there are more and more tests. So say within dev, you'll look at the source code and you will just really, really try and get fast feedback. The typical rule is, 5 minutes for the developer to go get a cup of coffee before they can know whether or not their code changes broke the build. And then as you get further and further towards production, there are much more in-depth tests that get run. So your performance tests, your dynamic tests, et cetera, et cetera, et cetera. Now this is your cloud native pipeline. Again, it is a flow from left to right in production. You can see a lot of the same tools sort of carry over. So you have Jenkins, you are working within Git, and this is a much more infrastructure aware environment. So when you are deploying into dev, the pipeline itself is aware of your container registry and it's updating as needed or as you are designing within your pipeline. And this is using GitOps, which I'll go through in a couple of slides, but just wanted to address that term here. So it's using GitOps to manage your infrastructure and your code. And it's using declarative statements throughout the process to define exactly what is going on. Cool. Just a really quick slide to highlight some of our key summaries. You have old school on the left with your traditional pipelines, and then new school, which is your cloud native environments. So some of my experience with inconsistent environments, excuse me. You will have your gold image that gets produced by your systems admin or your operations teams. And over time that developers tend to make changes too. So you'll have new dependencies, new configuration settings within each of the various development teams. And what ultimately happens is those sort of cascade out until the gold dev image no longer looks like the gold prod image. And that causes a lot of issues where you are not necessarily finding bugs until they are in production. And looking at some of the rollback process for those bugs, well, when you are in production, a lot of times you won't find out about issues until your help desk comes in with massive amounts of calls. And then in traditional pipelines, there is a large process that's needed, which costs a lot of money to then roll back all those changes. Whereas in cloud native environments, you have what's called canary builds, where you are able to set up with your load balancer and say, I want 10% of the people to our site to be redirected to the updated version, whereas the 90% will be going to the known stable version. And then of those people that get redirected through your load balancer, they can say, well, of those requests that come through, 5% of them are getting 500 errors. So based on the declarative rules that we have, we set that to know that the updated version is no longer stable. So then it redirects everyone back to the original updated version, the original known good state, and it kills the containers for the updated versions. So Cloud Native can automatically handle that based on the rules that you have declared through Canary builds. All right. And then I sort of mentioned this before, but everything is defined within your infrastructure, within your source code in Git. And so you need to manage your environments and make sure that that is well tracked, well documented, and you want to ensure that you are properly managing your branches. So where does security fall in? Well, you want to make sure that you're using multi-factor authentication, so you can specifically tie an individual user to, you want to specifically tie an individual user to their identity. Then you want to make sure that they aren't committing anything without signing it. So you want to ensure that all the attestations get signed for their commits. And you want to enable branch restrictions within the production, so that one single developer is not one single developer or a single team is not able to commit or push changes into the master branch, which becomes your production. And that's, cool. So one of the tools that you are using within Cloud Native is Spinnaker, which handles all of your communications. Now this tool is used for your communication. So it's very, very important that it is properly configured and set up. And much like your applications using microservices, this follows the same process. So you have Gate, you have Cloud Driver, Igor, Fiat, and Halyard. Now, Halyard is the configuration management service, which configures all the other services. Fiat is the authorization service, which checks to make sure whether or not something has, say, service level access and queries it before running anything important. Then you have Gate, which is the API manager. The API gateway itself. And I believe that's everything. Passing off to Jack.
Cool. So one of the things we have to think about in our kind of updated workflows is, where do we actually derive any value from the tests we run? So before we push and deploy things, there's different things we're going to see. After we push things to an environment, there's different integration tests we're going to see. Different things that, we can't necessarily blame the developers when somebody that runs cloud infrastructure makes like an S3 bucket public, right? So there's things we can verify before we deploy, but then there's, certain things that can happen after deployment that we want to know about, right? And those are unfortunately things that we're not going to get out of the way before we push. So it is important to get as much telemetry as we possibly can out of all the tools we use and all the different events we generate. So if we look at, for example, Spinnaker, right, handles deployment, not necessarily the integration and build side. So you'll generally hook something like Spinnaker up to Jenkins using webhooks and stuff like that. So all your systems are definitely very active in talking to each other. And the feedback loop is really important, right, because we can use that feedback to help our systems either recover in intelligent ways or let us know what's going on. So there's the whole world of chaos testing, right? Which is what can go wrong, and ultimately, how do we break our applications in the worst way possible? The stuff I'm talking about more today is verification, right? So verifying that certain preconditions are in place before you go live with code. So more on the verification side than experimentation side. So Jenkins X is another pretty popular cloud-native CI/CD tool. So it builds on Jenkins pretty significantly. It's pretty much Jenkins reimagined with an opinionated kind of workflow on top of Kubernetes. So who's worked with Kubernetes in here? So of curiosity. Who knows what a namespace is? Great. For anyone that doesn't know what a Kubernetes namespace is, it's essentially a logical isolation boundary where we can divide up things like role-based access control, networking, access to secrets. So the better segmented your architecture is via namespaces, and doing that intelligently, the better off you're going to be. So once upon a time, we kind of ran Jenkins and we had these big clusters. And we had a few centralized systems, right? And those were the kind of keys to get into production for some people. We run these a lot more decentralized now, right? So more teams are going to have their own instances. So I've seen environments where, CI/CD is kind of the security layer for, getting anything into production, and nobody touches, VMs and things like that. And now we're giving people access to the clusters, so we have to consider what can they do. So if we make the namespaces too muddy, too many teams, different applications kind of smashed into one place, then everybody has access to pull secrets, deploy applications, read that data. So we find that our development workflows kind of follow us right into production now because they're baked right into the cluster itself. Kubernetes, Jenkins X uses Tecton pipelines. So it's another way of essentially everything is going to be declarative, right? So it's YAML-based representation for your pipelines. The biggest distinction between Spinnaker and Jenkins X is that Jenkins X it's deeper integrated into Kubernetes via CRDs. So whereas Spinnaker introduces its own APIs, Jenkins X actually uses Kubernetes to do a lot of its API back stuff. So building pipelines, running tests, and stuff like that. There's all Kubernetes CRDs to represent those things. And you can also do things with Jenkins files as well. So there's essentially like the serverless mode, and then there's static mode as well, where you can use Jenkins files. So, but the big difference here is that everything's being driven in a GitOps fashion, right? Ideally, we're not giving people direct access to clusters, but that happens all the time. So we have security opportunities and challenges. So we have a lot more telemetry that we generate. We have a lot more events. So we can use those things for good, right? The downside is that once we start missing things like webhooks, that means we're missing builds, we're missing events. So we can also have, points of blindness if we just start missing events. With regards to observability, so we have the development systems we use. Then we have all the other tooling as well, right? From our cloud to our containerized orchestration systems to the things we can get from the containers themselves, right? So there's certain things, you'll get at runtime, right? Looking at a container and figuring out, which syscalls it's actually using. Granted, you can get some of that stuff through static analysis, but you can also run these things as well. So there's certain things that you certainly want to see from different stages. And you really want to be careful of the security opinionations that are in place for you. So one of the really nice things about both Jenkins X and Spinnaker is that they abstract developers away from a lot of detail. So you don't need to know as much about the cloud. You don't need to know as much about Kubernetes. The downside is that some of those opinionations might not necessarily match your tolerance for security and risk, right? So the way you kind of configure your cloud and do hardening and governance, it may be very different than the opinionations or minimal security built into these tools, right? So the goal is to get people up and running as fast as possible, not to make it as secure as possible and impossible to use, right? So one makes the developer happy, one makes everybody in this room happy. This is a developer tool. And failure is everywhere, right? So this is an example of a Kubernetes cluster. And there's a lot that can go wrong there in terms of failure. So first off, we have a control plane. I wish I had my little pointer thing, but you can see right here. This is pretty much the most important part of the cluster. So this is where the API server is. This is where, data representing the state of the cluster is stored. And all the deployment, resource management, that all happens from the control plane. So, if you're using a managed service, something like EKS or AKS, they'll handle the control plane, but then, for example, on EKS on AWS, you'll actually spin up, essentially virtual machines for each of the Kubernetes nodes, right? So there's a little bit that the cloud handles, and then there's a little bit that you're still running instances at the end of the day. So depending on how abstracted that is away from, if you have to manage it yourself, you have to harden the control plane. If AWS is managing it, you have maybe a little bit less of that to do, but some considerations. But things that can go wrong there, you can not do proper isolation of containers. So if you're running containers super privileged, or you're not, using all the rule-based kind of security execution around them, containers aren't really limited. They're limited by namespaces and control groups. Things like Docker, for example, they're not hypervisors. There's not really a security boundary, right? So there's a lot that can go wrong there. And, with addition to, using on managed services, right? How many people think that Kubernetes APIs are all over the internet, if you look for them, right? Like they're everywhere. People make these public, and as we'll see, like AWS and others don't necessarily make it hard for you to not do that. So then we also have code, right? Because everything runs inside of containers as code. So, the thing we kind of get lost in when we think about all the new pretty stuff is that at the end of the day, we're still running code, right? But the difference is our code is maybe a lot more abstracted from the things around it than it was at one point. So things to consider, right, is that your application just might not understand what's happening outside of the application itself. So container orchestration and runtime systems, the container is important to get right. So when we're testing, there's, things we can do locally, right? Run things like Docker Bench. There's a million tools. I hate to kind of get up here and be a tool evangelist. Go on Google and search for them. I guarantee you there's some good tools out there. But there's things you can kind of find those things locally, right? But there's also things you're not going to see with regards to container configuration until deploy time, right? Because there's certain things that, for example, Kubernetes, there's other container orchestration technologies out there. They can also mutate that state as well at emission. So you have emission controllers that can do things. And you can also have different wrappers, things like security contexts, and other things that can potentially change what you see inside of like a Docker file or locally. So if you want to have visibility of all the different kind of states, then you need to, test as you move through different environments, right? From local to actually running it in a cluster. Everything is declarative, so that's the good thing, right? So there's really not a lot of kind of guesswork. The good thing is that everything happens right away. The bad thing is everything happens right away. So the reconciler pattern is essentially always trying to reconcile towards the correct state, right? So it's always trying to move ahead, and as soon as it has updates for different things, it goes to immediately apply those to your resources. With regards to IaaS and PaaS integration, so if you are running your own kind of bare metal cluster, then there's a lot more that you'd have to do to get it to work with, say, like, EKS, right? So EKS, AKS, GKE, they're integrated with things like IAM, different platform services and everything like that. So if you're going to do things yourself like that, then you have to, consider key management, right? Credential management across your system. So I like to advocate for, if you can use the platform managed way of doing things, in some cases do that. It saves a lot of problems and things you have to think about later. The cloud is an interesting one, right? Because your applications now are running inside of containers that are running on orchestration systems, and then the orchestration systems are glued to your cloud infrastructure, right? So essentially your applications don't really have any idea what happens there. So as you're building, testing your applications, these are the kind of tests you start to have to consider running, right? When I go to deploy something, is the S3 bucket public? Can it be made public? Is the EBS volume encrypted that's going to be attached to this? Is the IAM role that's going to be basically injected has like allow all across AWS? Like there's certain things from a security perspective that you'd almost never want to happen, right? So these end up becoming things that happen inside of your integration tests and other parts of your test suite. IAM is where it really gets interesting, though, because if you have, for example, an IAM role or a user you create for a platform, right? And then you give that to a service account that then runs in a container. Depending on what you've privileged that at the cloud level is going to dictate what happens when that container gets compromised, an attacker starts to try to move laterally and pivot into other systems. So this is a newer thing, especially for AWS, just released recently the IAM to EKS. I know like Azure's done that for a while, GKE. But these are things to consider, right? Because once you create these accounts, you create subjects, you tie them to IAM, sometimes your developers start reusing them across applications. And then we have code that actually runs inside of these things, right? So, you know, I've heard this, right? It runs in the cloud, so like you don't have to think about security, and like it runs in containers, so like they're isolated at this point. No, right? Like you're still writing code, and in fact, like the code you write is more complex. We have more distributed systems, right? We have a lot more that can kind of go wrong. We have, you know, a lot of interesting things, like I've seen people that have migrated existing systems to, you know, cloud native architectures, and, you know, from fairly monolithic systems, and they start to run into things like race conditions, kind of concurrency related issues, where they move from like a monolithic workflow to using like something like Kafka, and passing messages around, right? Where there's just differences in terms of like how that flows. So that is really important, right? As you migrate existing systems to cloud native and then start to use cloud native tooling, you really have to make sure your security controls kind of follow with you. The way you test applications, right? So things like, you know, I'm not going to get into today, like running your static analysis, like dynamic tools, like IS, like dependency stuff, right? Those things don't change. Like you still have places in the pipeline to run all that stuff, right? So the way you test your code arguably doesn't change there. It's a lot of the other stuff that happens around it and integration, right? Things you won't actually know in the code until it's actually running in that environment, right? So just certain things that they get harder to mock out. So on the IAM side of things, depending on what you've allowed people to do inside of your cluster could potentially impact what they can do inside of your cloud. So from, you know, things like permissioning access to our container registries. So I see people do it a couple different ways, right? One is they put everything on the same cloud provider, right? So their source code management, their container registries, cloud stuff, like everything is under one hood, right? And they can use IAM, you know, minimize the credentials they pass around, access keys and stuff like that. So if you can do it all under one platform and that works for you, great. In reality, most people don't build like that. So it gets really important to figure out, you know, what can that service account actually do in the cluster and in the cloud. By default in Kubernetes, when you create a new pod, it'll use like a default service account. So I'll show an example of that like in Tecton here, right? So you can use, so this is if you want to create a pipeline using Tecton. It follows the same pretty much like, you know, it's essentially running on Kubernetes, right? So the way you'd run, you know, other resources, very similar. But as you run with service accounts, so if you're using like default accounts, which is a common pattern, right? So people will create a new pod, create a pod spec. They won't assign an account. And by default, it'll drop you into like a namespace default account, which is an issue because when each of those accounts runs with those same privileges, they have access to pull secrets, modify the container's kind of life cycle and everything like that. So it's really important to use separate accounts for each of those things. Essentially here, this is like that same thing kind of in a different place. With regards to namespace versus cluster level, so generally you don't need to give your teams that are operating in different namespaces cluster level privileges. So the whole goal nowadays is that if you're doing it GitOps properly, then you're not giving your developers access to the cluster to do anything. So they're updating their applications, they're doing all the deployments, all their modifications through Git. Right. So if you're doing the GitOps kind of thing correctly, then your developers shouldn't be able to use kube control and start doing stuff inside of Kubernetes API.
All right. So now we are going to focus back on the network and how to make sure that that is communicating properly without spilling too much, especially in the way of secrets. Cool. So everything can go wrong. A lot of these developers or whomever have a lot of faith in the tools that they're using. There are still very, very, very insecure defaults. So it's important and imperative that you set up network isolation so that you are controlling your blast radius. Essentially, you want to fail closed. So in the event that you are compromised or you want to prepare yourself to become compromised, you are limiting what might be exposed or what a compromised account will have access to. And you can see there was a talk a month ago now in Black Hat where they revealed that the EKS was publicly accessible by default. So that was a very, very, very big concern. You need to ensure that you are changing that and aware of it. Likewise, logging is disabled by default, which will help you clean up or identify where an issue occurs or clean up after an incident. So you need to ensure that you have that on. And you're able to connect to it without authentication. So again, a lot of very, very surprising insecure defaults that you need to be aware of, change, and plug those holes. So in terms of Jenkins and S3, the S3 buckets that get automatically created are unencrypted. So that's, again, something you want to change the default settings. It's also Kubernetes. Your Kubernetes is set up to be publicly accessible and publicly accessed. So those are some little tweaks here and there that you need to ensure that you are changing. Lastly, you have Helm and Tiller particularly, which again, you're able to access it without authentication, and it's a lot of the same problems over and over and over again. So you are storing your secrets in config maps, which are, again, potentially exposed, and you want to encrypt them. There's a lot of different methods you can use. One of them is HashiCorp's Vault. So if you keep your secrets in there, then you can have your various teams pass, if they need to use those secrets, they can pass them by reference, and your various teams can work together within the same environment without sharing secrets. Yeah. And don't do dumb stuff. So even without all the default settings, which you will need to go through and change, there are things that can sort of override the security settings, and they are named accordingly. There's the insecure flag that if you use, it turns off verification of your YAML files, which is a good way to get malicious code introduced into those configurations. So don't do things like use insecure flags, skip TLS checks, et cetera, et cetera. And I believe, okay, there you go.
Excuse me. So secrets management inside of a pipeline. So secrets are one of those things that either people handle those out of the gate when they build a system and they have a secrets management solution in place, or they get to production, everything works, and then they kind of get to clean up sprints and cycles, and they say, like, let's fix secrets management at this point, right? And then by that point, you know, secrets credentials have kind of sprawled out between their different environments. So as you use different tools, right, your CI/CD tools, Helm. So who's worked with Helm in here? We talked about Helm a bit today. Helm is, you know, first-class implementation inside of Jenkins X. You know, most cloud-native tooling is using, like, Helm and charts and for stuff for deployments. But you have to think about, right, secrets propagate to some of those layers. You have different tools with regards to different management tools, different integrations. So there's a lot of different places where you can inadvertently expose credentials. So it's one of those things, like, if you don't get it right kind of out of the gate, then it gets harder. Ideally, your developers, especially even at the Git layer, they're not handling secrets. If you're doing this stuff correctly, then the secrets are getting injected somewhere beyond what is going to happen at the Docker file, right? So this is, you know, at your Helm chart is a place where you can kind of wire up secrets and stuff like that. But ideally, inside of Kubernetes, the challenge is that you can use Kubernetes as secrets management API, but then secrets are still stored in plain text inside of etcd. So you can encrypt those, But it's kind of, it's a so-so implementation, right? A lot of people use Vault, right, to kind of move it out of there. And Jenkins X has integration with Vault. Spinnaker, I believe, has some integrations with Vault and everything like that. And the Vault integrations for Kubernetes are getting better and better, right? So if that's one of the things I can recommend kind of getting right out of the gate, it's managing secrets. And if you can avoid developers ever having a reason to manage those, then that's great, right? And if it can be done dynamically from day one, then even better. Long-lived credentials are bad. So any Azure people in here that use service principals and PIMs and they never rotate those things. Do people use access keys on AWS? Give them to all their developers and then they have them for 2 years and nobody does anything with those, right? Ideally, those are all really bad patterns. People shouldn't be using long-lived credentials for things like that. So if you can use things like STS, and if you can use platform integrated stuff, whether that's things like Kerberos, integration with IAM, anything to avoid having to have plain text credentials get stored anywhere. So they're on, when you have developers handling secrets, they're on their local box, right? Any test they run, right, depending on whether it's local, it gets spit out somewhere. Each of those interfaces is somewhere where potentially those things leak out. There's logs, there's deployment logs, so on and so forth. So the less places you can expose secrets, the better. I really can't stress that enough. And these tools are really extendable too. So I started playing around with just building a few extensions in Jenkins X. I forked it. It's on my GitHub if anybody wants to see some of this code. But if you basically run the JX scan commands, you could put anything after that, right? So there's one there for running Hunter, tool against Couponer rather. But I built one for Jenkins X, and I'm going to open source some stuff I wrote for RBAC. But there's different tests you can run, right? So Jenkins X gives you things like preview environments, which is your whole environment spun up in a namespace, right? Ready to be tested. So you can run things through commands and comments on a pull request, right? Where you can literally run different commands over and over against an environment. So it's nice to have as many of these utilities on speed dial as possible, and also to wire those up into your pipeline as well. So in this example here, it was a really simple example of playing around with a dependency check. Basically, what you end up doing is anything you run is inside of a container, and then it gets deployed. The way I have it set up is just like an ephemeral namespace that gets thrown away after the job runs. But it's creating itself as a batch job, and then it runs on Kubernetes, right? So if anyone's seen jobs run, there's nothing really too special about that. But nonetheless, it allows you to run any of your security stuff in a containerized environment in seconds. And here's just basically how you add those in. So it's Jenkins X. I mean, you're running it locally, so it would be nice if they build maybe a little bit better plugin interface for this at some point. But I mean, it's early days for the tool, right? There are plugins, but not underneath JX Scan. This is pretty much all that's available for now. Under scan, but pretty much you add your command at that point, and then you can do JX Scan, whatever tool you want to run at that point. And one thing to note, security management and governance, right? Especially in the cloud, it's nice to pick up the different tools that they kind of give you to manage, harden things out of the gate. What you end up finding, especially in the cloud native world, is that sometimes there's not full support, whether that's alerting and logs or integration with some type of strong authentication. So as you're picking up the new cloud native kind of hotness tools, you really want to do your research to make sure that the platforms you're using them on have all the things you're looking for security, right? Things that you get out of the gate always are pod security policies and some of that emission control based stuff. So there's a certain amount of stuff that you want to just basically opinionate out of the gate, right? What developers can do. Can you run containers as root, right? Those are things you should, at a higher level decide, right? And you should implement policies. So when your developers go to push containers as root and they can't do it, everybody's happy at that point, right? Because nothing went wrong. And asset inventory gets incredibly hard, right? So if you look at Most of the tools, they do a good job at cloud-based stuff, or there's tools to get good visibility inside of your clusters and containers. Where it's getting maybe a little bit better is, aggregating all that stuff. So has anybody gotten on the service mesh bandwagon? Has anybody used Istio, like Envoy? Has anybody heard of those things? So they're really nice because they allow you to inject like sidecar containers that sit next to your container, and then you can proxy traffic. So you can do things like end-to-end, mutual TLS. You can get all the logging metrics that you want out of that. So if you're using service meshes, then you actually do get a really good extension of visibility. Other than that, I've found that there's definitely a lot of kind of jimmy rigging tools together at this point to kind of get a view. Because you do want to know when people push stuff, right? That's new things appear. You kind of want to know about that. So in conclusion there, don't break the feedback cycle and pile up security debt kind of on the left-hand side. There's a lot of stuff we can do at our cluster level, things we can kind of opinionate up front for our developers. A lot of it has to do with how we lay out things like GitOps and how well we obey kind of some of those rules, right? If we are doing the GitOps thing and then we're giving people like direct cluster access, we've broken a lot of the kind of advantages, right? If we're having all of our infrastructure and code in one place where it's auditable, right? Like I go through SOC 2 at my company every year. Has anybody SOC 2 Type 2? It's the most miserable shit in the world, and they ask you dumb questions for 2 days. But it's great because like moving to this model, it's like, here you guys go. Here's literally our Git, right? If you want to know why we made a certain change to our network, it's all auditable in one place. So just as a business, we found that this has even had a benefit from that perspective. You want your engineers to move as fast as possible, right? Like I'm one of those security people at this point in my career. I'm like, just let everybody just write code. Business has to work, right? But we want to put as much in place to make sure that they don't just kind of shoot themselves in the foot, right? And so again, how we basically lay these things out from an IAM perspective, network segmentation, hiding secrets, and just enforcing good practices all around. And last but not least, applying controls at the levels they make the most sense, right? There's certain things that if you try to apply it to a Docker file, it's a waste of time. There's a better place to do it at the container orchestration level. And likewise, there's certain things that you have to think about, still at the cloud level as well. Because if you, for example, put all of your container nodes, or if you have multiple clusters, you put those in the same VPCs, like now they can all talk to each other, right? So you can do good stuff from a development perspective, but if your infrastructure is broken, then things aren't going to work well either. So that's our talk, everyone. Thank you, and happy to take any questions.
And we got 5 minutes left for questions, and I've got a microphone if you have one. It remains silent.
Thank you.
Sorry. Do you have any experiences you could share with Helm? Because I'm curious, like to know more about.
Particular specifics about it, or?
Not really. Just to know if you had like any experiences, like things I should look at. You could share.
So his question was about Helm and anything we could share about securing Helm. So I'm really looking forward to Helm 3 and the whole tillerless approach, right? So a lot of the security issues with Helm came from the tiller. And just how that was kind of set up. And so a lot of deployment issues, right, for how people kind of overprivilege that tiller, and then they'll leave like the gRPC endpoints open and you can talk to that thing, right? So from that perspective, I've seen just like a lot of deployment-based issues with how people do tiller or Helm, right? Because the tiller is a major component of it. But in Helm 3, there's the whole tillerless approach, right, which solves a lot of that. So some of the things with like managing Helm service itself get better, but then it still gets down to like managing your charts, right? Because that's a place a lot of people haven't managed like charts, right? So they've tooled around container registries and code, but they're like, oh well, charts. Well, how do I like control and access that? How do I like scan those things, right? How do I do all that stuff? So that's the other place I see people, usually when they go that model, they have to build maturity around how do they manage like the charts and everything like that. But is that a good answer? Does that answer everything you asked for?
Yeah, that's helpful. Thanks.
Cool. Anything else, or that should be it? Thank you, everybody, for your time.
Thank you.